Given the following infinite series, which is effectively the sum of the terms in the following sequence. And we can't always get a closed form expression for the nth partial sum of the series, so we need to introduce some tests to determine if the series converges or diverges. And one of these is the nth term test, which checks if a series diverges. So this test checks if the limit of the sequence, as n approaches infinity, is not equal to 0 or does not exist. And if one of those conditions is true, then the series diverges. And really have a think about why that is. And we'll do a few examples to demonstrate the test. Let's determine if the following series diverge using the nth term test. And this is one of the tests that we use for infinite series, where there's no closed form equation for the partial sum. Well, this test tells us to take the limit of the sequence that corresponds to this series. And in this case, it's equal to 1. And because it's not equal to 0, the series diverges. Now if we take the same step for the next series, well, in this case, the limit is 0, so the test is inconclusive. Because regardless of this sequence converging, the sequence of partial sums may converge or diverge. So this test only tells us if a series diverges. Now for the final series, this sequence keeps oscillating from 1 to -1, so the limit does not exist, and the series diverges.